Welcome. We are going to do a quick look at homework 1.4. So here we go. Click on homework 1.4 and take a look at this questions. Now this is just a mix and match question. Given this situation, they want to know which goes with this. The only one that I think you might kind of wonder about is population. I'll just tell you that one. That goes with box. So what they're trying to get is this idea that your population can be represented by the elements of their box method. That's their analogy. So the rest of them are all pretty, pretty obvious. Your sample is your draws, the draws out of the box, and so on. All right, question number 2. So there are 20,000 students of whom 10,000 are older than 25. That's half in this scenario. These will randomly regenerate. The registrar draws a simple random sample of 400 students, find the expected value and the standard error of the number of students who are in the sample. So our expected value, well, if it's half, we are expecting 5,000 because 50%, if that's half, so random sample of 400. So we're expecting 200, right? Our standard error then, in this case, is the square root of our percent of those who are older than 25 times the percent of those who are not. That is our standard deviation. Remember, it's the box standard deviation times the square root of 400, which is 20. Right, so we get that. All right, expected value of the percentage, we take that 200 divided by 400, and we write, let me do this number real quick on my calculator. The square root of 0.5 times 0.5 times 20. So we have the square root of 0.5 times 0.5, and taking the square root of that. And times 20, 10. So this one, our percent, and we're going to put this in cent, is 50%. And our standard area percentage is 10 divided by 400, just 10 divided by 400 is 2.5%. And so we know the percentage of students who are older than 25 will be around 50%, give or take 2.5. And we hit submit, and voila. And what? Everything all looks green and good. Awesome. All right, next one. Coin will be tossed, and they want to know what is the formula. So in order for this matching to work, there had to be an equal number on the left and the right. So the problem that was presented to me didn't have an equal number, so there's one of these formulas that's not used. So you just match that to the one that's not used. So how would you calculate the standard error of a coin tossed 10,000 times? So for the percentage of heads. $500 are selected at random from a box as 0.00, and then this is just true or false, so I don't really want to answer them for you, but just, the number of ones among the draw, is exactly equal to the sum, that should say draw, I'll fix that. And then the expected value for the procedure is exactly equal. For the percent, the expected value for the percent is exactly equal to 25%, true or false. So we'll fix the autocorrect there. And then someone plays a dice game 100 times. On each play, he rolls a pair of dice and then advances the token along the line number. For a total number of squares equal to the spots thrown. So if I roll the dice 7, I go to 7. And if I roll it another 7, then I go to 14. And if I roll it 2, then I go to 16, and so on. How far does he move, give or take how much? So you can explain here how you figured that out. What's the expected value of a roll of dice for, for rolling a pair of dice? What's the expected value? And then from that expected value, what's the standard error? Where do I expect to be, give or take how much? So that's what we're asking for here in this essay question. So I'll be able to read those answers. Hope this video was helpful for as you get started, and let me know if there's any questions. Thanks, bye. See you guys later.